Hello everybody, welcome to the JavaScript course. In this video, I'm going to discuss custom exceptions. It is achieved by inheriting a built-in error class, so we can create our own exception from the built-in error classes. And also, I'm going to show you that a generic exception can wrap its subordinate exceptions. So we will see an example to demonstrate this effect. Now, let us go to the HTML file first. The HTML file is rather simple. It just has a title and a heading. And this HTML file is linked to a JavaScript file called myscript.js, which is stored in the JS folder. So let us go to the JS file. In order for me to use the strict mode, I have to say use strict on the first line of the JavaScript file. And after that, I'm going to explain the meaning of custom exceptions. Actually, we can create our own exceptions to handle the more specific errors of our choice. So the creation of a custom exception starts with inheriting a built-in exception. And when we can inherit a built-in error class, we can inherit the properties from that built-in error class. For example, the name, the message, and the stack can be inherited. Okay, so let us see an example to really create an exception based on the built-in error class. Okay, this part is rather long, so I'm trying to explain it to you part by part. So I want to set up my permission error class, which is a custom exception class based on the built-in error class called error. And I'm trying to set up a constructor for my permission error class. So I have a parameter called message. Okay. And the message is just trying to show the meaning of the permission error object. So I can just inherit the message from the error class. That's why I use the super keyword. And after that, I can change the name of my permission error and the message for my permission error. So the name becomes permission not allowed, and the message is just the message of used in the constructor of my permission error class. Okay, so the subclass uses the same message as the base class does. That's why I can use the constructor, especially the super keyword. And when we do so, the super keyword helps me to inherit all the properties from the base class first. And it is mandatory to start with the word super. That is quite trivial for us because we already know that the super keyword has to come first in the constructor. Okay, and the message is the first parameter. Okay, so that's why I have to use the message here in the super keyword. And then I can change the name and the message as discussed. So that is the way to set up my own exception called custom exception, and the name of it is called the permission error. Okay, so how can we apply the permission error class? I can show you an example like this one. Now I have a function called test input, and I can enter the name, and if the name equals Peter, I will say, oh, Peter is not allowed to enter the system. So I would say Peter has committed the permission error. So I would say, oh no, Peter is not allowed. And if I don't enter Peter, I can just say that the input is accepted. So that is the way to set up my test input function. And let's see how we can call that function. We call the function in the try catch finally block. So I call the test input in the try part, and if there's some error coming out, I catch the error, and of course I can show the content of the error by showing the message, the name, and the stack. And of course, whether or not the error can be caught, I will still go to the finally part. So that's the major way of calling the test input function, which has a possible error called permission error. Okay. So let us see how we can run the program. Save. reload. Yes, I want to enter the name. So I enter somebody else, like Anna. So Anna would then commit the permission error. That's why I would expect that I can go to the input accepted alert window. Yes, input is really accepted because I don't really enter Peter, which will throw a custom exception called permission error. And of course, after finishing the try part, I have never reached the catch part. I just go to the finally part as the final step of my code. And how about entering Peter, which will cause a permission error? Let us see. Okay, Peter is entered. You can see that, I will have, permission not allowed. What does it mean by that? I can really throw a custom exception object called permission error, and then this error will be really caught in the catch part, and the catch part will show some content of the alert windows. And the first alert window is saying that the message is called oh no, shown here. The oh no part is already mentioned in the constructor. So when I pass this oh no to the message variable, it will just become the first message of the permission error. And this part is called permission not allowed, which is just the name of the error. Okay, the name is shown here. So after I show the message called oh no, which is passed to the constructor, I'm able to show the name of the permission error. Okay, and I'm going to show you the second alert window, which represents the stack of the function, which tells me the position where the program will go to the exception. Line 26, column 15. So I'm able to throw the exception. And line 33, column number 5, is just that one. So when I call the test input function, I'm able to throw a custom exception object called permission error. So that is the origin of the problem of the current code that results in the exception handling. Okay. Of course, I have to say input finished because whatever the result coming from the test input, I'm still able to go to the finally part. That's why I'm able to show the input finished statement coming from the alert window. Okay, the other part is called exception wrapping. So the meaning of wrapping is that a generic exception wraps other subordinate exceptions. We would know there is a generic exception, but not as detailed. So we can have a top-level exception that wraps all other exceptions of the same nature. And then I'm going to show you an example to illustrate the wrapping effect. Okay, the code is a bit long, so I explain the code step by step. So the first thing is to set up my custom exception called input error, which extends error. So error here is the base class, and the input error is the derived class or the subclass. And how can I set up my custom exception? I use a constructor to pass the message and the cause of the error into the input error constructor. So the message is the first parameter, which must be the case. Cause is an optional parameter following the message. So we don't always include the cause in the constructor, but we have to include message as the parameter passed to the constructor all the time. Same for the first example, where I have to show message in the constructor. This is mandatory. Okay. And then we can go to the content again. The content of the constructor says that we set up the message, and we just use the constructor of the superclass. That means the superclass is the error. So I just use the message of the original error class, and then for the name and cost, I can just set up my own name called input error and my own cost called cost. So I'm trying to set up my input error by passing the cost to the input error object later on. So here we come to the wrapping. So I have another two classes. One is called invalid base error, which extends from the input error. So I have a custom exception class, and that exception class is going to wrap the two custom exception classes. The first one is called the invalid base error, and the other one is called invalid exponent error. So you can expect that I'm trying to do multiplication by using the base and exponent. We want to get the power of some quantities, and let's see how we can apply the invalid base error and the invalid exponent error in the upcoming function called getPower. So we can see the content of the getPower function. I have three quantities called base, exponent, and power. So I get base from the prompt, I get the exponent from the prompt. So if the base is not really a number, I can just throw the invalid base error object, and you can see that I have two parameters to be passed to the invalid base error constructor. Okay, why are there two parameters? When we refer to the constructor of the input error class, which is actually the base class of the invalid base error class, we can see that I have first the message. The message is just base and not an integer, and the cost is the second part of the constructor, which means the base should be an integer. So I'm going to pass two strings. The first one is called the message, the next one is called the cost. So the input error can help me create an input error object, which is now extended to the invalid base error class. Same for the exponent part. If the exponent part is not an integer, I can throw an invalid exponent error. So this invalid exponent error is extended from the input error class. So I'm trying to use the same constructor to handle the creation of the invalid exponent error object. So I input the first string being the message and the second string being the cost. Okay. So if both exponent and base are numbers, then I can just create the power as usual. I can find out the power and show the power using the alert window. So that is the major idea of the getPower function. I do the checking to see whether the exponent or the base are really numbers. If that's the case, I can get the power pretty easily. So let us see how we can make use of the getPower function. I put it in the try-catch finally block. So when the getPower function is called, I really need to check for the exception objects that are thrown by the getPower function. So if I really catch some error objects from the getPower function, I have to check whether that kind of that error is an instance of the input error. If that's the case, I can print out the content of the error, and I can also print out the cause of the error. So the input error is that thing created in the class shown here. And since both the invalid base error and the invalid exponent error are derived from the input error, when I discover either the invalid base error or the invalid exponent error, they are actually an instance of the input error class. That's why the corresponding message and the cost will be shown up on the alert windows. Okay, and finally, I would just say that the end of the program is reached in the finally part. Okay, let us see an execution example of the code shown here. Save, reload. As I enter some number for the base first, maybe 4, and exponent maybe 3, then I can get 64 because I can go to the else part directly, and I'm already safe to see that both the base and the exponent are not strange characters. They are both numbers. That's why I can go to the else part safely to get the power. Of course, I'll go to the end of program part because the get power function is executed properly, and I never go to the catch part. Then I will just go to the finally part of the. So let us see another example in which either the base or the exponent is not a number. The base is I. The exponent is 4, maybe. So you can see that I will go to the invalid base error, and you can see that the error message is that the base is not an integer, which is just this statement. Okay, that is passed as the message of the error. Okay, that means I'm going to do this first alert window because I already know that the invalid base error is an instance of the input error due to the derivation shown here. Okay, so I'm able to show the message. I'm also able to show the cause. The cause is just saying that the base should be an integer. Okay, that is the second parameter to be passed to the constructor of the input error object. Okay, of course I will show the end of program. Yes, because I just go to the finally part after doing the catching of the error. So let me show you another example. Base is 3. Exponent is a character called P, maybe. So I will have another error called exponent error. Invalid exponent error would come out. So I'm able to show that the exponent is not an integer. That is the first parameter of the object. And this becomes the message. So I show the message here. And the second alert window will show the cause. That is the second parameter to the constructor of the invalid exponent error. Okay. So we can see that both the invalid base error and the invalid exponent error are instances of the input error. That's why no matter the error we generate, we will still go to the alert windows shown here. And of course, I will go to the end of the program alert window because I've already handled the catch part, and I just now go to the finally part safely. Okay. So this video has already talked about the meaning of custom exceptions. We can create our own exceptions by using the constructor of the base error class, and after that we can throw that custom exception object to the catch part, and then we do the handling. And also we have talked about exception wrapping, which means we create some error classes from base custom exception class. Okay, so this base custom exception class is able to handle the derived classes using the same constructor, and then we can just catch the wrapped exception objects and we can handle them as usual, because those errors are just instances of the base custom exception class. This is the end of the video. If you have any questions about my video, please leave your questions on the comment section below the video. If you like this video, please give me a like and please subscribe to my channel. Thank you for watching.